everyone. Welcome to Try Rights, the new era of learning. Myself, Rafiq. So let's move to the topic. Today's our topic is k-fold cross validation. Okay. In machine learning, most of the concept is depends on k-fold because it is a part of train and test. Okay. If you are building any model or any concept, we must use to train and test the data. Okay, or data sets. For that, we use k-fold cross validation method. So to get strong, okay, what is k-fold? No, k-fold validation is nothing but is a technique to split the data sets into k equal parts, okay, or folds. Like guess a simple example, like if you take a paper sheet and fold it by half of the paper, half of the little bit, not half of to 50-50 tone, or if we can fold like 20% of paper and another fold. Like that, the concepts may train the data, okay. The model is trained and tested for k times, okay. Number of times the data will trained and test, okay. If the trained data gets to the test, if the tested data can come into train, okay. Equal times the different fold has a test sets and the remaining folds has the training sets, okay. Here we can see the definition. It is a statistical technique to measure the performance of a machine learning model by dividing the data sets into k subsets of the equal size folds. Okay, depends on the data size. The model is trained on k minus one fold and tested on the last fold. This process is repeated k times. Okay, which each fold can be used the testing set exactly once. The performance of the model is then averaged overall k iterations to provide a robust estimate of the generalization ability. Okay, careful validation versus testing. Okay, validation versus try and test split. While careful cross validation partitions the datasets into multiple subsets to it, to try and test the models. Okay, here we can see the highlighting parts. That try and test split method divides the datasets into the just two parts. Okay, reading the definition is getting too bored. Okay, I explain genuinely by manually, not by reading this definition. I explain by easy. Okay, let's wait. Let's see here one example. If the mm, structure difference between those two methods, the first image shows the train test split method where the datasets is divided into 80% of the train and 20% of testing segments. Okay. Now, how it is works? Splits the data into k-fold. We already discussed about it into five parts. For each iteration, use k one fold. Okay, k minus one fold of for training. For remaining one fold for testing. Okay. Repeat the process k times, changing the test fold and each time. Average the result. Okay, these are the steps we use in the k fold. Okay, and most of the candidates guess why use k fold for cross validation. So it is helpful to reduce the risk of overfittings, gives a more reliability estimates for the model performance. Okay, single train or test split efficient use of data. Okay, every data point is used to both training and testing. Okay, each and every single bit of data get tested and trained by dividing the parts into k-fold. Okay, by 20% or 30% or 40 according to the data set. Okay, oh, let's we can see here it has the most benefits also. Okay, helps the hyperparameter turning. Okay, less based, better estimate. Okay. So it is a diagram. See here we have a one single data set here, and we want to train the 20% of data testing into testing, and the remaining 80% into training. So like that we split the data into two parts. Okay, the fold will be rotate up to the edge of the data sets. Okay, so this is the our original main data set, and this is the five-fold cross validation. Because if you're dividing the 20%, it may get five folds. Okay, right? If you're dividing the 10%, it may be get 10 folds. Okay, depends of the percentage when you're dividing, then we can easily estimate the fold. Okay, now see the down from downwards is starting testing After that, the testing data get into the train. After the remain trained data comes into testing. Like that, we split up to the edge of the corner, edge of the data. Okay, edge of the k fold. So trained data and tested data, both our data have equal percentage. Okay, train model and evaluate model. So both models were get trained and tested at a time. Okay. See, in iteration one, the data gets trained first. Okay, now for test. After remaining all data get it into train. Okay, let's it 80%, it 10%. Okay. In second iteration, the k fold may be 10 this side. Okay, the k fold may turn this side. Okay, let us explain in simple terms for you. Wait a second. Okay. Now you can see the image here. Okay. Now, okay. So first here we start the data. Okay, right? Here we start the data, right? After that, it folds turns into here. See here. Okay. After this, the trained data here comes into here. Okay. It splits the data. And after this, the fold will be here. The k fold must be here. And it get into test. Like that, the test of the 20%, 20% like this, it will move from the edge. Okay. This test data comes into the here train, and after this into test, and it moves forward, and it move into the test. Like that, every each and every part of the data percentage will be trained and tested at a time. Okay. Usually we most of the before k-fold we use like we train the data separately and we test the data separately. It is wasting the most of the time, and it is not a proper building of a model. So at that concept we use into the concept comes into the picture k-fold, and it used to evaluate the all of those data sets estimates, and in that the fold at a time the data set with the processing at a time it train and test. Okay, see here the data will like this. Okay, and this like the data will divides in number form like this: one, two, three. Like after one, after two, after three, after three, one will get test, and next will be moved to the two, and one will get trained at a time. Okay. In this, we also having rolling cross validation. Keeping those points in mind, we perform the cross validation in this manner. We create the fold or subset in a forward changing fashion. Suppose we have a time series for stock prices for a period of n years, and we divide the data yearly into a n number of folds. The folds would be created like irritation training set 1 and test 2. Training 1 2 after 3. It is estimating data like prediction type. So we take train 1 data for test 2 data. So after that, this test 2 gets into the train after it introduce 3. Like that, same method also here using from n number of times. Okay. Okay, let's move to the code. It is nothing but used to check the machine score. Okay, how much the model get trained and how much the model get test. Okay, and the common value of k is for typically k equal to 5 or 10. Usually depends on the percentage. Okay, if you assign 30%, the k if you assign the 20%, the k will be fivefold, and if you assign 10%, the k will be 10%. Okay, like that. It depends on the data. If the data set is small, a higher k like 10 is better. Okay, if for a large data set smaller k like 5 can be save time. Okay. In simple terms, we can say as cross validation is a robust method to evaluate the machine learning models by splitting the data into k parts. Okay, using each part into once into the test and train. Okay. Uh, no, wait. Okay, it is not bit. We can just explain the code. It is not larger code, a simple code. I already done this. So not that much, which but just K-fold is just for use for train and test. We already speak about it. So for that it tests the model score and okay score percentage. So here we import the SKLN data sets. Import like yesterday we discussed about the iris data set. Okay, it is a type of flower. Okay, from that we select cross validation. Okay, score, and we imported a logistic regression, decision making classifier, and support vector machine. Sorry, support vector, and after that random forest classifier. Okay, and after that we use numpy. Okay, this numpy is for calculation. Okay, we import this machine. It supports this all machines. Okay, line by line we check for the logistic regression. We can see the data of the score of it. NP average score is 0.97 is nothing but 97% it gives the score of by testing data like 20% of testing data, right? Okay, from 20% we take as here. It's used to check the score. Okay, for training the data. Okay, and after that we train the okay decision tree classifier. We train into decision tree classifier. After that we can see the decision tree average. Here we have the overall function here, and we see the NP average score of the this. So it's catered to the 96% of 0.96%. I already said about this. 0.5 means 50%, 0.9 means 90%. If 0.05 means it get 5%. Here we get 1 means it will totally 100% in calculation. Okay. So here we can see support vector machine. So it's also the score has highest 96. Okay, 96.66 percentage, and after that last random forest classifier. Okay, we can also see the 95%. So in here we can see a common random forests get 95%, and what's SVR gets super support vector machine gets 96%, and decision tree classifier gets 96. Okay, we can see the highest data set. Here we have the logistic regression. Yes, right? Yeah, yes. Logistic regression has the highest score result. Okay, like this we can from the starting onwards we use this concept because we are trying the data, testing the data by 20%, right? Here we can use this code like this. Okay, in simple terms, previously we did decision making tree, right? Okay, where the decision making tree, random forest. Okay, this okay, it is data, right? Okay, we can see here in this data, we can see here we train the data like this. Now see here, this here we can see this concept we import from these two lines. From SKLine, we import the model selection, import, train, test, split data, right? This is the main concepts of the K-fold. Okay, here we split the data for the X train, X test for Y train and Y test. After that, we split the data into size. Like in finally, we mentioning the 0.2 has 20% of the data. Like here we discussed 20% of data like this. It moves the 20% of train and test. Okay, like that the data will be moved forward until the iteration will be done as completely. Okay, like this K-fold works in the machine learning model. I hope you guys understood. Thank you all.